Guys, welcome back to Tech Tutor. In today's video, we're going to start talking about operating systems and what are operating systems and how they play an integral role in our day-to-day lives. And we're going to start off with the introduction first, explaining terms and we'll see how it goes. Okay, let's see. So these are some of the things we'll go over. What operating systems are, what is their organization, architecture, the operations that you can do with them, the resource management, security and protection, the virtualization features, distributed systems, data structures, the environments, and the open source OS. Um, some objectives, again, to be able to start talking about operating systems in general, and get down into what they actually are. So an operating system is basically a intermediary service that runs between the hardware of a computer and the software element and the user applications, basically, right? It in other words, it's also a kernel that always keeps on running. So what is a kernel? A kernel is a system service that keeps on always running. More in terms, an operating system is a program that acts as an intermediary between a user of a computer and the computer hardware. Okay, so intermediary service, it's in the middle. It doesn't itself do it, but it provides, provides like a liaison, like a bridge between these two things. The goals of an operating system: execute user programs and make solving user problems easier. Make the computer system convenient to use and use the computer hardware in an efficient manner. Coming to the structure of a computer system. So the computer system can be divided into four components. Again, we're not talking about the OS, we're talking about the computer system in general, right? So you have four different components. First component is the hardware component. The hardware component, what does it provide? So the hardware of your computer, think about it. So you have the CPU, right? You have the memory, the input-output devices, right? Um, we're going to talk about the memory and the different types of memory in the coming slides. The input-output devices like your mouse, your keyboard, right? So that's the hardware element. Then comes our operating system, the middle, okay? That controls and coordinates the use of the hardware among the various applications and users. Then comes the user, right? The user application program. So like I open up a word processor, compilers, web browsers, all right, these slides, opening up this presentation, those are the application programs. And who are the users? Users, me, you, right? It could be machines also as the users and other computers also. So these are the four main components: hardware, OS, application programs, and users. Next, looking at a view. As you can see, the main well of this diagram is to show you that operating system is that middle layer between the application programs and the computer hardware. So what do they do? So so there's a couple of views to see. There's a system view and a user view of what a operating system does. Uh, so the operating system, it again does there's some different views of what it does. It helps with, just to remind us, it helps with the use and good performance. It doesn't care about users in general. They don't care about user utilization, resource utilization, right? Me and you care that we are able to do what we are able to do on our computers, right? But when you have like a shared computer, like these huge computers, right? Or a computer that has limited capacities, it must keep all users happy, right? So what the operating system, what it does, it's a resource allocator, right? It allocates resources to their users so that it doesn't blow up on those resources, and also a control program to make sure the users to make sure it can redirect resources, redirect these applications, so it makes efficient use. Then also workstations, right? But then what if those workstations have limited resources where you have to share among a pool of people, right? Even mobile devices all have OS that help with resource management. Some computers, right, also have these So some computers also have little to no user surface. In that case, also you need an operating system that helps manage those resources. So again, defining this a little bit more, it covers many roles. We see OSs everywhere, from computers to phones to even toasters, right? Spacecraft, game machines, right? So, and an interesting thing is when this came out is when the military became more general purpose and needed resource management and program control. Again, so there's no universally accepted definition of what a OS is, since there's just so many things it does. But you can think of it as a program that keeps on running. As I mentioned before, a kernel that keeps running on the computer. It's either a system program, so it helps with the operating. It comes with the OS, right? So a system program like allocating CPU memory, or it could be an application program. So everything that's not uh, you know a system, everything of a computer, right? Of the programs that exist, it could either be a system program or an application program. Now again, an application program is not as are those programs that are not associated with the OS. So example, these presentation slides, Google Chrome, right? And OSs in today's times, they also include middleware. So what is middleware? It's the set of frameworks that provide additional services to developers, such as databases, multimedia, graphics, right? The thing in the middle between, again, what the resource hardware resources, and we think about the user applications. Now coming to the overview of the system structure, we defined the OS, what is an operating system, and we're going to talk about the computer system structure in more detail. Coming to the computer system organization, if we look at what a computer has it can have one or more CPUs, a device controller. A device controller comes with whatever the device is. So it could be, here it says disk controller, right? It could also be a USB controller. It could be a HDMI controller. That controller acts between this bus. We call it a bus. Why? It's like a line that connects all the components, right? It connects all of them together, but also to shared memory. Okay, so this bus provides access to the shared memory. Now, the CPU can run. So why these are like connected like this is because all of them can run concurrently or at the same time. Okay, so device controllers, we're gonna see device drivers also later, how they're also a key component. Coming to the operation of like what are the system in general, the different operations that happen. Uh, Again, as I was mentioned, they can happen concurrently. The CPU can run at the same time as an I/O input device runs, right? Each device controller, as I mentioned over here, it's responsible for a specific device, like a USB or a disk. Each device controller has a local buffer, and it also has an OS device driver. As I said, we were going to talk about it. A controller also has a device driver to manage it. That manages it. So see, and then the CPU, what it does is it helps move data from. Moves data from the main memory and the local buffers. So the local buffers are on the controller, and it helps move the main memory to and from there. And the input output is from the device to local buffer or of controller. The controller informs the CPU that has finished its operation by causing an interrupt. Right? We're going to talk about interrupts, but know that device controllers are what sends those interrupts to the CPU, saying that a task. Now I'm moving this cursor, right? The device controller has some registers allocated by the device driver. Device driver is closer to this. So device driver, you can think over here, and that sends that allocates some registers on the disk controller. This controller, so after moving this cursor, I stopped. And then the disk controller sends a message to the CPU, an interrupt to the device to the CPU and also the device driver, saying that it's done. And what does it do? It gets those registers back on the device driver. If that didn't make sense, we're going to talk about it later also. So yeah, just know this is what it sends. The device controller sends the interrupt. So what interrupts? What are interrupts? Interrupts, they transfer control to something known as the ISR, the interrupt service routine, through the interrupt vector. Okay, interrupt vector is like a matrix, right? Saying that a matrix of that says that this is of a higher urgency and this is of a lower urgency. CPU, it sends a message to the CPU. Hey CPU, you interrupt, and then CPU stops its task and gets to the interrupt, and the interrupt service routine runs. Okay, so yeah, and so basically with the address, where is that address of the interrupted instruction saved? It's saved in the interrupt vector. Uh, and a trap or exception is a software-generated interrupt caused either by an error or a user request. And in OS, as we see, is interrupt driven. So our OS primarily is interrupt driven. So this is kind of like a flowchart showing an input-output device. It could be my touchpad right now, moving this cursor. It's idle, but when it's running, input-output request, as you can see that you see that low and then that high, interrupt signaled, interrupt handled, and then the interrupt, and then again you get that request, transfer done. It's you see that pipeline that happens. Interrupt handling. So the OS preserves the state of the CPU by storing the registers and the program counter. It, and it determines which type of interrupt has happened. There's types of interrupts we're going to see in a bit. And separate segments of the code determine which action should be taken for each kind of interrupt. If we talk about the interrupt drive input-output cycle, right? This flowchart shows how an interrupt happens, right? So again, we have the CPU, we have the controller, right? A device has like a touchpad, a USB port, right? It has a controller associated with it. So a device driver what happens is the device driver initiates the input output. Okay, it receives a signal from the controller, and then the controller initiates that input output. Then the input is ready, and output is complete. Then the error generates, right? And then the error happens, generates interrupt signal, right? And then CPU is checking, right, if there's any interrupts that it has received. But until then, it lets the controller do a thing, okay? And then the CPU receives the interrupt and it transfers control to interrupt handler, okay? Then the interrupt handler, it processes the data received and it returns from the interrupt. Where does it return from the interrupt, and where does it go? It goes to the CPU, and the CPU resumes the processing of the interrupted task. Okay, so again, device driver initiates the I/O, and then the I/O controller, and then this is how the flowchart looks like. Coming to the input-output structure, there's two main ways of handling the input-output. After the input-output starts, the control returns to the user program only. When does it return? Only after the input-output completion, right? But there's another way. If the after input-output starts, control returns to user program without waiting for the input-output completion. Okay, so it could either wait for the input output to happen, or the control could do it without the completion of the input output. The two main ways. More about this from this slide, I would just say, so basically system call, knowing that the system call, that's a key term, that requests the OS to allow users to wait for input output completion. Okay, and then this table, device status table, it contains an entry for each input output device. right? So this mouse, this cursor, then the USB, then the HDMI, and the OS operating system indexes it into an input device table to determine device status and to modify table entry to include the interrupt. We'll be doing this more in the next video. Please join me in the part 2 of this video. Thank you.